Welcome to CHAKUA International. I'm Nilavatana speaking. The salient features of various type of power station. These presentation from engineers previous year questions electrical machines and power system for engineers preliminary 22. The salient features of various type of power systems. The hydroelectric plants, ample quantity of water at sufficient head and possibility of constructing a dam to store water in the catchment area are decisive factors. And the cost is highest, fixed cost around 10%, variable cost practically nil because water is free, and transport of fuel nil, maintenance cost comparatively low, transmission liability very high, running cost low, time required completion 7 to 10 years, simplicity cleanliness simple and clean, can be used supply peak load and base load, sample robust and most reliable, space need a lot of space for civil engineering construction work such as dams. Building has to be much larger than the required for the other type of plants. Then thermal, generally located near the load center, but other factors such as transportation of fuels, enough water for cooling the condensate, cost of land are also kept in view. The initial cost is lowest, fixed cost around 13%, cost of fuel high, transport of fuel very high, maintenance cost higher as compared to hydro and diesel, transmission liability low, running cost high, time required for completion 3 to 4 years, simplicity and cleanliness causes air pollution, disposal as causes air pollution disposal as is another problem generally used in supply of base loads. Reliability less reliable need much more space than the diesel electric station but much less than compared to hydroelectric station. Nuclear located near the load center, easy transportation of the nuclear fuel, availability of cooling water, and burial of radioactive waste determine the site for the nuclear power station. And cost is moderate, fixed cost 15%, variable cost is also low, transport cost is seen to quantity of fuel required very small, transport is virtually very low, maintenance on the high side as the skill and well-trained staff is required to handle the equipment, transmission liability low, time required completion 7 to 8 years, and clean source of power generation which does not contribute to air pollution. Handling of equipment need very complicated. Nuclear waste disposal is however a major problem. The used for supply of base load as the reactors cannot easily control to respond quick to load changes. Reliable, need less space. Then diesel can be installed anywhere and the cost is moderately low. Fixed cost is 15% and the variable cost is very high. And the transport cost higher than the for nuclear stations but lower than that of thermal power stations. Maintenance cost comparatively low, transmission liability virtually nil, running time of completion less than 1 year, simple and cleaner than thermal plant, used to standby supply part load in a power station, also used in supply peak load demand in conjunction with hydrothermal nuclear stations. Less reliable, normally small sizes of space is required. Terms commonly used in system operation: connect a load, the sum of the continuous rating of the load consuming apparatus connect to the system, formed by the power intended to be always available. Cold reserve is that reserve generating capacity which is available for service but not in operation. Hot reserve is the reserve generating capacity which is in operation but not in service. Spinning reserve is that generating capacity which is connected to the bus but ready to take load. And diversity factor, sum of the consumer's maximum demand to the maximum load on the station. Load factor, average load demand by maximum demand. Plant capacity factor, actual energy produced divided by maximum possible energy that could have been produced. That means average demand by installed capacity. Plant reach factor, actual energy produced divided by plant capacity into time the plant has been in operation. A transformer works on the principle of mutual induction. Steps down the voltage. RMS EMF induced in the coil is 4 per F and 5M. The transformer classified core type cell type. As ideal transformer has no magnetic leakage, zero resistance of winding, and its core has infinite permeability. The phasor diagram transformer shows the phasor relation between primary and secondary voltage, currents, and voltage drops. The per unit method is very convenient. The voltage regulates the change in secondary terminal voltage when the rated load at a specified power factor is removed. It expresses the percentage of rated secondary voltage. Quantities of maximum efficiency when the copper loss is equal to iron loss. All the efficiency energy output in 24 hours divided energy output in 24 hours plus energy losses in 24 hours. A DC machine may be DC generator, DC motor. DC generator converts mechanical energy into DC electrical energy, while DC motor converts DC electrical into mechanical energy. The main part of DC machine: field poles, yoke, armature, commutator, brass, and intervals. Armature winding of DC machine may be lap winding, wave winding. In lap winding, the number of parallel parts is equal to number of poles, but wave winding number of parallel parts is 2. The EMF generated ZP phi n by 60A. Commutator converts AC to DC and DC to AC. Armature reaction, the effect of armature flux on field flux. It may be demagnetizing or cross-magnetizing. The use of high resistance carbon brushes and interpoles helps commutation process and reduces arcing due to commutation. The magnetic characteristics show the variation of open circuit armature voltage with field current when the generator running at constant speed. The self-action is due to residual magnetism. A synchronous generator converts mechanical energy into AC electrical energy. To keep the output frequency constant, it must run at a synchronous speed. Synchronous generator has armature winding on stator, field winding on the rotor. It may be cylindrical rotor machine or silent pole machine. Cylindrical rotor machine have horizontal configuration of 2 or 4 poles and are used in thermal plants. The silent pole machine have large number of poles, run at slow speed, are used in hydroelectric plants. The exciter system may be brushless exciter system or static exciter system. Thyristors are used in static exciter system. The effect of armature reaction can be represented by inductive reaction XA. The sum of the XA and linkage reaction XL called the synchronous reaction XX. Voltage regulation, a change in terminal voltage when load current is reduced to 0. It is expressed as percent of full load terminal voltage. Voltage regulation can be estimated by synchronous impedance measure, MF methods, some saturation synchronous method, a zero power factor method. For silent pole machine, power output is equal to 3BE by divided by xt sin delta plus 3B square xt minus xq divided by 2xq into sin 2 delta. For power output for cylindrical rotor is equal P is equal to 3B divided by xs into sin delta. The 3-phase induction motor is a single excited machine. It's stator paired with 3-phase AC, but the rotor is not given any supply. Rotor may be wound rotor, squirrel cage motor. Wound rotor has 3-phase winding, has the same number of poles as the stator. The terminals of rotor winding brought out to slip rings. The squirrel cage rotor has a number of conducting bars laid in slots of rotor coils. The end of these bars are short circuited by contacting rings on both sides. Slip is ns by ns minus n by ns. 3-phase induction motor develop torque at all speed except synchronous speed. The speed of 3-phase induction motor is always greater than the synchronous speed by about 3 to 5%. Both stator and rotor may be rotated in synchronous speed. In some cases, operation of 3-phase induction motor is similar to that of transformer. The equivalent circuit helps in analyze the performance. Losses in 3-phase induction include stator couple losses, stator core losses, rotor couple losses, friction windage losses, and stray losses. The 3-phase induction motor has a positive starting torque at 0 speed. The maximum torque occurs at about 3 to 5% speed. A wound rotor induction motor is started by additional resistors across slipping. A cage induction motor is started by star delta starter. At the time of starting, the stator winds are connected to star. When the motor picks up speed of connection changes to delta. Double cage rotor has 2 sets of rotor bars. It has high starting torque. Method of speed control, 3-phase induction motors include the frequency control, pole changing, line voltage control, rotor resistance control, and cascade connection. With this, to present the company, like it, subscribe, put the bell icon. Thank you.